Welcome to this tutorial. I'm going to solve question 4c from Necta 2017 Basic Applied Mathematics paper, and it's Form 6 level. The topic today in this video is application of differentiation. Okay, so I have done videos on 4a and 4b, and that's why they are crossed, and in this video I'm doing 4c. The question says, a 13-meter long ladder leans against the wall. The bottom of the ladder is pulled away from the wall at the rate of 6 meters per second. How fast does the height on the wall decrease when the foot of the ladder is 5 meters away from the base of the wall? Okay, so let's just do a little sketch here. We have a wall, and there's a ladder which is 5 meters away from this wall. So here we go, we have a ladder, goes like that. So this ladder is 13 meters long and it's been pulled away at the speed of 6 meters per second. And what else do we have? We're asked for how fast, so that is speed, does the height on the wall decrease. So the height at the moment is this one here, the vertical height, so I'm going to call it y. We need to say how fast, when this ladder is being pulled away, how fast does this height decrease? In other words, what's the speed of this ladder when it's been pulled away and it goes down? Okay. What do we need here? So we need speed going down this way, which means we need dy dt. That's what we need. Okay. What do we have? Well, we have dx dt is equal to 6 meters per second. What else do we have? We have x. We have the horizontal distance, which is 5 meters. And then we have this. So we can find y, for example, here. We know we need to find this distance, and then we need to apply the information, the data, onto our next process. Okay, how do we find y here, first of all? Well, this is the vertical wall. Okay, so it's going to be 90 degrees there. Beg your pardon. So that means we can apply the Pythagoras theorem to find y. So what do we have? 5 squared plus y squared equals 13 squared. So y is the square root of 13 squared minus 5 squared, which means y is 12 meters. So this is 12 meters. Okay. What else can we do? We want dy dt. We've got dx dt. That's the distance, horizontal distance. So that's a speed. So distance over time. That means that is the horizontal speed. Okay. Well, we are going to introduce differentiation here. That's the only way we can do. And we're going to differentiate with respect to x. So what can we do? What can we get? Where can we get this information? Well, we have x horizontal here, distance, and we have y. And we're going to apply the same thing, the Pythagoras theorem. So what we have, x squared plus y squared equals 13 squared. And if we differentiate with respect to t, okay, so what do we have? We're going to use implicit differentiation here. Okay, so we have 2x and then we have dx dt plus 2y dy dt, and that's going to be equal to differentiation of a constant is 0. Okay, we can simplify here and divide by 2 throughout, and then make this part the subjects, because that is what we're after. So y dy dt then is going to be equal to minus x dx dt, which means dy dt is going to be equal to minus x over y times dx dt. Well, we have x, we have y now, and we have dx dt. So therefore, dy dt is going to be equal to minus x is 5 and y is 12 and dx dt is 6. So simplify, that's 1, 2, and this will give you minus 2.5 meter per second. Okay, so therefore the speed is going to be minus 2.5 meter per second. Okay, all right, thank you for watching and see you again.